Okay, so the first thing I want you to write down is this. 1 per square inch gauge equals 27.7 inches of water column. So 1 inch of pressure, gauge pressure, will push water in a water column up, if you was measuring, 27.7 inches. Well, what is 27.7 inches equal in feet? 1 psig equals 2.309 feet. Right? 0.433, a fraction of a psig, equals 1 foot, 12 inches of water column. Equals, so one per square inch of gauge pressure equals 2.309 foot of water column. Okay, so now you can see on your math, let's break what we just did down. 1 psig of pressure. You want to know how much, let's say you had a water column broken down into inches. What is 1 inch of water column? Take a straw and suck it up 1 inch, and that's 1 inch of pressure. Here, we're saying 1 psig, square inch of pressure, not 1 inch of water column, 1 square inch of pressure equals 27 inches of water column. So you suck that liquid up 27.7 inches, and that's 1 psig of pressure. Now, that is 27.7 inches converts to 2.309 feet. 1 fraction of a psig, 0.433, is what equals 1 foot, 12 inches of water column. So let's break this down a little bit. If we take that 0.433, that gives us 12 inches of water column. Plus 0.433 equals 12 inches of water column. 0.7 psig equals 0.143 of water column. If we add these fractions up, we get 1 psig, 1 whole psig, which equals 27.7 inches of water column. You have to learn that. That'll be on your journeyman prior. I know it's on my contractor's exam. All right? You have to know what 1 psig equals 27.7 inches of water column at 2.309 feet. Okay, so we need to know this right here, your book's saying, because they want you to do a quick math formula. Okay, so now look what your book says. You have water here being pulled and circulated by a pump up through a pipe and back down in. Notice on the entry you have 0 pressure. The pressure differential created across the pump circulating the water is 2.165. So we want to know with 2.165 how long a pipe run can you circulate that water. Okay, we know what the pressure is of the circulating pump. Now, how far in pipe can that water be circulated? So have you figured out how to do that yet? Well, it says it in your book right there. What we want to know is if it's 2.165 is your PSI difference in pressure, what is the length in feet it can press? Well, what did we say was the fraction to use for per foot? 0.433, correct? So let's do that. We're dividing here the difference in the pump pressure by feet. And this comes out to 50 foot. Got it? That comes out to 50 foot. Now let's go ahead and do an example here, practice. Okay, I want us to go ahead and do some samples here. 20.5 would be the pressure here. 22.85. 24.55. and 23.85. That is the difference here, 4 different differences that this pump could pump. Now I want you to tell me how many feet each one of these could pump. Okay, and the next code word is zoom. All right, so let's go look in what we got here. Over the foot conversion here, when we create the division to figure out what it is per foot in pipe, we get 47.34 feet. For 2285, we get 52.77 feet. For 24.55, we get 56.70 feet. For 23.85 pressure differential, we get 55-foot run of pipe. Now, I want you to notice something right here. With your book on 979, it says, the power consumed by the motor driving a centrifugal pump is proportional to the quantity of water the pump circulates. This might, okay, so it requires more, so it says in the example, the pump operating under the conditions. In 32.1a, look at that, you have 30 psig, 5 coming out, and notice you got 20 amps being drawn. That says it requires more horsepower when operating under these conditions than shown 21.2. Okay, so look at this right here. In picture B, you have 5 coming out and 50 head. 50 psig coming. Now look at this. 15 amps. The flow has been throttled 30 gallons per minute. Here, it's being throttled to 0. And you draw in 10 amps. Okay, so look what your book says. This might sound counterintuitive. When a valve is installed in the piping circuit and it's closed, it would seem it would create a greater rise in pressure to increase the head pressure against it. But it doesn't, because it's a water circulating pump. It's not a compression pump. So the water is creating a pressure difference, and when you cut the valve off, it just sits there doing this in the water. So notice the amps went down, and then there was no water movement. So that's what's going on in that page right there, okay? Now, let's go on to the differences on page 981 of the different parts of the thing.